This video is going to look at solving rational equations. Before you can understand what goes on in this video, you need to make sure that you are familiar with the concepts of finding a least common denominator, factoring, and solving quadratic equations. All of them will be used extensively in all of the examples. Also, this video seems a little bit long, and that's just because I work a lot of problems in it. Once you start to get the hang of it, you can skip to the recap at the end, but you feel free to go back and look at any of the examples that you skipped. So, rational equation. Well, that's just an equation that has fractions in it, and we need to solve for the variable. So, in the previous videos, we looked at just expressions. There were no equal signs in them. In this one, we are going to be having an equal sign, which makes them equations. So we're going to be looking for x. Let's start out with the easy one. Say I had 2 over x equals 5 over 10. Some of you guys are looking at this going, oh, well, I can solve that one just using common sense. And that's fine to do. They get a little bit more complex, though. So I'm going to show you the steps to solving rational equations with this easy one so you can kind of check your answer. One thing that's different about rational equations is that you need to be very careful about making sure you exclude values that x cannot equal. So we have an x in the denominator. Let's just imagine that x ended up being 0. Your equation would be 2 over 0 equals 5 over 10. Is it possible for you to divide by 0? No. It is impossible to divide by 0. Therefore, in order to solve these equations, one of the first things we're going to need is look for something called a domain restriction. Domain restriction is just finding the numbers that would make the denominator 0 and making sure that you exclude those from your answer set. So in this case, the number that would make the denominator 0 would be 0. So x cannot equal 0. That's our domain restriction for this problem. Alright, so now we want to solve this rational equation. This one's not too bad, and I could use cross products. However, the easiest way to solve any rational equation is to multiply through by the least common denominator. So in this case, the least common denominator needs to include the denominators of all the fractions. The least common denominator needs to include x from the first one, and it needs to include 10 from the second one. So when we multiply through by this least common denominator of 10x, we are going to end up with 20x over x equals 50x over 10. Now we can see that there's some simplification that can happen. The x's can cancel on this side, and I can actually factor out a 10 on this side, so that my equation becomes 20 equals 5x. Divide both sides by 5, and we get x equals 4. Now, if I look at my domain restriction that x can't equal 0, it's okay for x to equal 4, and we've solved our rational equation. I want to look at another simple example before we look at anything too complex, because we multiply through by the least common denominator. We actually don't really need to multiply everything by that least common denominator. We're going to be able to simplify a little bit faster. So for this problem, I can see that my domain restriction is based on that factor. X cannot equal 0. If it does, I'm going to have an error. So now I can find my least common denominator. The least common denominator needs to include x, needs to include 3, and it needs to include 7. So I would say my least common denominator is 21x. However, I'm going to leave it in factored form so you can see what I'm going to do in just a second. So let's multiply through by the least common denominator. Our goal is to clear the fractions. We don't want to have any fractions left over. Now if I multiply the first fraction by my least common denominator, the x's are going to cancel out, and all I'm going to be left with is 3 times 7 times 1, which is 21. Then when I multiply the second fraction by my least common denominator, the 3's will cancel out. So I'm going to be left with 2 times x times 7, which is 14x. And in the last fraction, the 7's will cancel. So I'm going to be left with 5 times x times 3, which is 15x. So you can see that I was able to clear out those fractions very quickly here because I kept my least common denominator in factored form, and I knew what would eventually cancel out. I didn't do that step in the previous problem because I wanted you to see why it works that way. It's not just magic. So let's go ahead and let's solve this. I need to get all my x's over there together. So then I end up with just 1x on that side and 21. So x equals 21. Now, that would be your final solution, but you need to make sure you check the domain restriction. According to my domain restriction, x can't equal 0, so it's okay for it to equal 21, which means my final solution is x equals 21 with the domain restriction of x is not equal to 0. Alright, so let's look at some more challenging ones. So for this problem, we have x in the denominator. We also have 2x in the denominator. Those two things are going to help me find my domain restriction. So if I have x, I know that it can't equal 0. So x is not equal to 0. That's one part of my domain restriction. I also have the factor 2x, and I know that 2x can't multiply to be 0. So divide both sides by 2, and I know again that x can't equal 0. So my domain restriction for this problem is just x is not equal to 0. Now let's go ahead and multiply through by the least common denominator. The least common denominator in this case needs to include x for the first fraction, needs to include 2 for the second fraction, and needs to include 2x for the third one. But luckily enough, we already have 2x represented in our LCD, so I can multiply through by only 2x. Now the first fraction looks like the x's are going to cancel, and I'm going to be left with 2 times 2, which is 4. In the second fraction, the 2's will cancel, and I'll be left with 1 times x, which is x. And in the third fraction, the whole thing cancels, and I'm left with just the numerator, which is 5. Now it's just a matter of getting x by itself. So when we solve this one, I'm going to subtract 4 from both sides. I'm going to end up with x equals 1. Now don't forget about your domain restriction. My domain restriction says that x cannot equal 0. Well then, I'm okay. X can equal 1, and that's my final solution. For this rational problem, it's a little bit stickier to find the domain restrictions. I want to figure out what number would make x minus 3 equal 0, because I know I don't want that. I don't want that denominator to equal 0. So when I actually solve my domain restriction, I'm going to get that x cannot equal 3. That's the domain restriction. Since the two denominators are the same, I'm okay with just that one domain restriction. Now we need to find the least common denominator. They both have the same denominator, so x minus 3 is the least common denominator. Now to clear that out, I'm going to multiply the whole equation through by x minus 3. So I'm going to end up with the x minus 3 canceling out, and I'm going to be left with just 3x in the first fraction, equals, again, the x minus 3's are going to cancel, 2x plus 3. Now let's go ahead and solve our problem. Get our x's together. And it looks like I'm all done. But wait! The domain restriction says that x cannot equal 3. And I found that x does equal 3. So in this case, since I know that x equals 3 but doesn't work, I actually have no solution to this problem. So we can say no solution, or another way that you can write that is a 0 with a slash through it. There's no x value that would make this true according to the domain restriction. If it were to be x is 3, we would end up with fractions that are erroneous. We can't divide by 0. This is why the domain restriction is important to find. We can even solve fractions with subtraction in them. So here this equation is two fractions equal a whole number. Just to remind you guys, a whole number is a fraction over 1. So when I'm going to be thinking about my domain restriction, I know that 2x can't equal 0, and I know that 3x can't equal 0. In both of these cases, I'm going to get the same domain restriction. I know that x can't be 0. X can be anything else in the world, whatever I solve for it to be, but it can't be 0. Now we're going to multiply through by the least common denominator. The first fraction says, well, I need 2x. And the second fraction says I need 3x. Well, I already have x represented, but I'm going to need to add in the 3. The last one is just 1, so I'm good there. So my least common denominator is 2 times x times 3, or 6x, if you want to think about it that way. So let's go ahead and let's multiply through by it. I'm going to keep it in factored form so I can see what's going to cancel. 2 times 3 times x. So when I multiply the first fraction, the 2's will cancel, the x will cancel, and I'll be left with 3. So my numerator is going to become 3 times 3, which is 9. When I multiply the second fraction, the 3's cancel and the x cancels. So I'm left with 2 times 5, which is 10. And in the third fraction, I don't have anything to cancel out. So I'm left with 2 times 2 times 3 times x, which ends up being 12x. Now we just have to do a little bit of work to solve. So I'm going to simplify the left-hand side. Negative 1 equals 12x. Then get x by itself by undoing, divide. And I get x equals negative 1/12. I know I also have a domain restriction of x is not equal to 0. Since negative 1/12 is not the same as 0, I'm done. That's my final solution. X is negative 1/12. If you plugged it back into the original equation, you would get a true statement. Alright, so this time, when we are looking at our denominators, we need to double check to make sure that the denominator of x minus 7 will not equal 0. 2 will never equal 0, so I don't need to worry about that one. And x minus 7, the other denominator, I already have that represented here. So when I solve for my domain restriction, I know that I can't have x equal to 7. That's the number that would make the fraction be over 0. Now let's look for our least common denominator. According to the first fraction, I need x minus 7. According to the second fraction, I need 2. And according to the third fraction, I need another x minus 7, or I need x minus 7 represented at all. Well, I already have that in my least common denominator, so I can multiply through by it. I'm going to multiply through by 2 times x minus 7. That's an x, I swear. Alright, so let's multiply the first fraction. I know the x minus 7's will cancel out, but the 2 stays. So I'm going to have 2 times 2x minus 9. I look at the second fraction, the 2 will cancel, but I'm going to be left with the x minus 7 still. So I'm going to have x times x minus 7. And in the third fraction, the x minus 7's cancel, so I'm left with 5 times 2, which is 10. Now let's do a little bit of distribution to see what we really have. I have 4x minus 18 plus x squared minus 7x. I know that this equals 10. Now again, let's do a little bit more simplification. I'm going to combine some like terms, and I'm going to rewrite it more in standard form. So I have x squared minus 3x minus 18 equals 10. So this is a quadratic equation. If we think back to when we solved quadratic equations, for most methods, you want to have equals 0. In a lot of these types of problems, they factor pretty nicely, so I'm going to try that first. I'm going to subtract 10 from both sides. So I'm going to end up with x squared minus 3x minus 28 equals 0. Then I'm going to factor. We need to think of numbers that multiply to be negative 28 and add to be negative 3. Well, in this case, I'm going to have x minus 7, and I'm going to have x plus 4. So when we solve our equation, we end up with x equals 7 and x equals negative 4. Don't forget about your domain restriction. The domain restriction says that x cannot equal 7. which means I'm going to have to cross out one of my answers. I can't include that one. However, the second one is okay. So we can say that x can equal -4 as long as x is never equal to 7. Usually you end up having an extraneous solution when your final evaluation is involving a quadratic. Not always, but a lot of the time. So it's important to check your domain restriction. Speaking of domain restrictions, this one is going to be doubly restricted. I need to make sure both of those denominators are not going to equal 0. So I need to make sure that x plus 1 doesn't equal 0. And I need to make sure that x minus 2 doesn't equal 0. Well, for the first one, I need to know that x is not equal to -1. For the second one, x cannot equal 2. Otherwise, that denominator would be 0. So I have my domain restriction ready to go. Now let's look for the least common denominator. The first fraction says that I need an x plus 1 in the LCD, and the second fraction says that I need an x minus 2 in the LCD. Remember that 2 is just 2 over 1, so I really don't need to worry about that being represented in the common denominator. Now let's multiply through by that big old common denominator we found. Leave it in factored form so you can see what cancels. For the first fraction, the x plus 1 will cancel, and so I'll be left with x times x minus 2. For the second fraction, the x minus 2's will cancel, so I'll be left with x times x plus 1. For the third fraction, nothing cancels, alas, so I'm left with 2 times x plus 1 times x minus 1, minus 2. Which is really big and gross and messy, so we are going to simplify, and so we're going to do a lot of distribution. X squared minus 2x plus x squared plus x equals 2 times x squared minus 1x minus 2. Looks like I can simplify that right-hand side a little bit more, and the left-hand side as well. So I'm going to combine some like terms and do some more distribution. Isn't it cool how algebra builds on itself? I keep telling you guys that all the time. All I'm doing is using skills that we've previously learned. That's why you had to learn them in the first place. So x squared and x squared leaves me with 2x squared on this side. And negative 2x and x leaves me with just minus x. Equals, on the other side, 2x squared minus 2x minus 4. Now, since this looks like it's going to be a quadratic equation, I'm going to try to get equals 0. You can get equals 0 on either side. I see that I have more stuff over here on the right, so I'm going to move the stuff on the left to become over there. So to move that 2x squared, I'm going to subtract it from both sides. To move the x, the negative x, or minus x, I'm going to add x to both sides. So I'm going to end up with this equation. 0 equals, score, those cancel, negative x minus 4. So it actually doesn't work out to be a quadratic at all. I need to get x by itself. There's a lot of different ways you can do this. I'm going to choose to move the 4. So I end up with 4 equals negative x, divide by negative 1. So x equals negative 4. Now don't forget about your domain restriction. The domain restriction says that x cannot equal negative 1 or 2. Since negative 4 is different from those, I'm actually good. I can say that that's my final answer. If you have watched any of the other videos, you've noticed that everything has this first step of factoring. That's what I need to do now. I'm not going to be sure what my domain restriction is until I factor everything that's possible. That fraction on the right-hand side does factor, so that's my first step. So my equation is going to become 2 over x minus 3 minus 4 over x plus 3 equals 8 over, conveniently enough, a difference of squares, which becomes x minus 3 times x plus 3. Now we can go ahead and talk about our domain restriction. which is going to say, what is not going to make the denominator 0? Well, I need to make sure x minus 3 doesn't equal 0, or x plus 3. I would have already checked both of those by doing the first two fractions, so I'm good there. That means that x cannot equal positive 3 or negative 3. All I did was solve those two equations for what values would make them 0. Now our least common denominator. Well, the first fraction needs an x minus 3. The second fraction needs an x plus 3. The third one also needs an x minus 3 and an x plus 3, but that's already represented, so I'm good to go. Now we're going to multiply through by that least common denominator. Leave it in factored form so you can see what cancels. For the first fraction, x minus 3 cancels, so what we're left with is 2 times x plus 3. For the second fraction, x plus 3 cancels, so we're left with minus 4 times x minus 3. And for the third fraction, everything cancels, so all we have left is 8. So now let's do some math. We'll do some distribution to see if we can't simplify this, find what x needs to be. 2x plus 6 minus 4x plus 12 equals 8. Now we have some like terms to combine. So we end up with negative 2x plus 18 equals 8. Now we can go ahead and solve. This one isn't a quadratic, so I don't have to worry about factoring or anything like that. All I need to do is isolate x. So I'm going to subtract 18 from both sides. End up with negative 2x equals negative 10. Divide both sides by negative 2. And we get, I'm going up here now, x equals 5. Now don't forget about your domain restriction. Got to check with that first. X cannot equal positive or negative 3. Since 5 is different from those numbers, I'm done. That's my final solution. The value of x that makes that equation true is 5. So as I promised in the beginning of this video, I'm just doing lots and lots of examples. Some of the next few examples are going to get a little hairy though, so you might want to double check before skipping ahead to the end and saying you got this down. So the first step is to look for things that factor. In this case, I don't have to worry about that. The second thing is the domain restriction. I need to make sure that x minus 1 does not equal 0. Well, the value that would make those equal 0 is 1. So my domain restriction is just x is not equal to 1. The least common denominator. Well, the first fraction says I need an x minus 1. Second fraction says x minus 1 as well, so I already got that covered. The third fraction, though, needs a 6, so I need to add that in. Now let's multiply through by our least common denominator to clear our fractions. Equations are so much easier to solve when there aren't any fractions. So when I multiply the first fraction, the x minus 1's cancel out. I'm left with 1 times 6, which is 6. The second fraction, the x minus 1's cancel out, so I'm left with x times 6, which is 6x. And in the third fraction, the 6's cancel out, so I'm left with x times x minus 1. So now let's do a little bit of math and let's simplify what we can. 6 equals 6x plus x squared minus x. Aha! I'm going to have a quadratic, so I am definitely going to need to get equal 0 on this one. First I'm going to combine like terms though. So I have 6 equals, let's see, 5x plus x squared. Now I need equal 0, so I'm going to move the 6. I'm going to subtract 6 from both sides. So I end up with 0 equals x squared plus 5x minus 6. So now we're going to look for things that multiply to be negative 6 and add to be 5. Be really careful with this one, it's kind of tricky. Multiply to be negative 6 and add to be 5. It ends up just being x plus 6 and x minus 1. So when we solve this thing, I'm going up here, I end up with x equals negative 6, and I end up with x equals 1. Don't forget about your domain restriction, though. The domain restriction says that x cannot equal 1. So that is an extraneous solution. I can't use it as part of my answer. So my final solution is just x equals -6. Because of the domain restriction, x cannot equal 1. Otherwise, we would divide by 0, which is crazy and impossible. This example has a pretty complex denominator. It means we're probably going to have to factor it. So if we look on the left-hand side, it looks like I can factor that to be x times x minus 1. The number 1 doesn't really factor at all, and this last fraction doesn't factor either. Now that I have this set, I can go ahead and do two things: my domain restriction and my least common denominator. For the domain restriction, we need the factor x to not equal 0, and we need the factor x minus 1, oops, that's a minus sign, I swear, to not equal 0. So I end up with the domain restriction of x is not equal to 0, x is also not equal to 1. That's my domain restriction. For our least common denominator, the first fraction says I need an x and an x minus 1. The second fraction is just 1 over 1, so I don't need to worry about that. And the third one needs an x minus 1, which I've already taken care of. So we can go ahead and multiply through by x times x minus 1. So it looks like for the first fraction, everything cancels out. Yay! And I'm left with just the 2. The second fraction, there's nothing to cancel out, so I'm left with x times x minus 1. And in the third fraction, the x minus 1 cancels out, so I'm left with just 2x. Now let's go ahead and do some simplifying. We're going to have to distribute. So I have 2 equals x squared minus x plus 2x. Combine your like terms. So we have 2 equals x squared plus x. And hurrah, this is a quadratic, which means we need to move the 2 and get equal 0. Subtract 2 from both sides. We end up with, 0, I swear, equals x squared plus x minus 2. So now I'm running out of room, so I'm going to move up to the top again. And it looks like I'm looking for numbers that multiply to be -2 and add to be 1. So that works out to be x plus 2 and x minus 1. Be really careful with your signs. I needed them to add to be a positive x, so I needed the 2 to be the positive 1. So when we solve this thing, we end up with x equals -2 and x equals 1. Now check your domain restriction again. The domain restriction says that x cannot equal 0 or 1. Well, I don't have to worry about the 0 so much, but I do have a 1. So that answer does not work. It would give us that divide by 0, which we do not want. So our final solution is just x equals -2, including the domain restriction of x not equaling 0 or 1. This is a good one because we have to factor a whole bunch. Yay! Look at that first denominator. Pretty gross. Let's simplify it a little bit by factoring it so we can find our least common denominator as well as our domain restriction. I'm looking for numbers that multiply to be 12, but add to be -8. Since I know they're multiplying to be a positive and adding to be a negative, I know that they both have to be negative. So I end up with x minus 6 and x minus 2. On the other side, I don't have any fractions or anything that needs to get factored, so I can go ahead and just write it as is. Now that I have it in factored form, I can clearly see that my domain restriction is going to have to be x is not equal to 6, nor is x equal to 2. Those are the two numbers that would make anything under any of those fractions equal 0. I can also find my least common denominator. The first fraction says, well, you need an x minus 6 and an x minus 2. The second fraction just needs an x minus 2, and I've already got that covered, as well as the third fraction, where I needed the x minus 6. So we can go ahead and multiply through by our least common denominator and see what cancels. Sorry I'm squishing everything in, but I want to keep it all on this one page, and I don't want to have to go to another one. Alright, so for the Left-hand side. Everything cancels, so I'm left with 4. For the next fraction, x minus 2 cancels, but I still have x times x minus 6. For the last fraction, x minus 6 cancels, but I still have 1 times x plus 2. Or sorry, minus 2. So we can simplify a little bit. We're going to end up with 4 equals x squared minus 6x plus x minus 2. Then we can combine some like terms. It looks like I have a couple pairs of x's. So I will end up with 4 equals x squared minus 5x minus 2. Now we need to get the it to equal 0 because this is a quadratic. So I'm going to subtract 4 from both sides. So I end up with 0 equals x squared minus 5x minus 6. That's what we're going to factor. So I'm going to move up to the top here. Now I'm going to think of numbers that multiply to be negative 6 and add to be negative 5. Again, this one's a tricky one. You totally want to use 2 and 3. I know you do. But in this case, I need to use 6 and 1. It's going to be x minus 6 and x plus 1. You can always check yourself by redistributing these guys that you just found and see if they match what you're supposed to have, if they matched your x squared minus 5x minus 6. Alright, so now we can solve. Based on these factors, I know that x equals 6, and I know that x equals negative 1. But my domain restriction says that x cannot equal 6, nor can it equal 2. So it looks like we have an extraneous solution. We can't use that one. That means we only have x equals negative 1 for our solution. And our domain restriction that caused us to only have that one solution was x is not equal to 6 or 2. Doesn't this one look like amazing amounts of fun? I know I'm excited. I hope you are too. Let's factor. X minus 2 over x plus 4. Doesn't factor. Plus x plus 1 over x plus 6 equals 11x plus 32 over, multiplies to be 24, adds to be 10, x plus 6, and x plus 4. How convenient for us, right? So that means our domain restriction, based on all those factors, is that x is not going to equal negative 6, nor can x equal negative 4. That would give us those erroneous answers. We can also find our least common denominator from here. Our least common denominator needs to include x plus 4, and it needs to include x plus 6. If I have those things in my least common denominator, then I'm good. It's covered. All 3 fractions are covered. So let's multiply through by that least common denominator so we don't have these horrible fractions anymore. For the first fraction, x plus 4 cancels out. So I'm left with x minus 2 times x plus 6. For the second fraction, x plus 6 cancels out. So I'm left with x plus 1 times x plus 4. Thankfully, for the last fraction, everything cancels out, and I'm left with just 11x plus 32. So now we have a lot of distribution to take care of so that we can simplify this thing a little bit. Oh, math is so much fun. Alright, so we get x squared plus 4x minus 12 plus x squared plus 5x plus 4 equals 11x plus 32. Combine like terms. So we have 2x squareds plus 9x's minus 8 equals 11x plus 32. So this is definitely a quadratic, and I'm going to need to get equals 0. To do that, I'm going to take away this stuff on the right-hand side, which means I'll need to take it away on both sides. So when we do this, we're going to end up with 2x squared minus 2x minus 40. I have a GCF. This will make my life a little bit easier. Let's factor that out. This is 2 times x squared minus x minus 20. So that's what I need to worry about factoring. That 2 isn't going to make a difference. In fact, I could divide both sides by 2 if I wanted to, and then factor from there. So I'm looking for numbers that multiply to be negative 20 and add to be negative 1. So I think we end up with x plus 4 and x minus 5. Which means our two solutions are x equals negative 4 and x equals 5. Don't forget about your domain restriction, though. My domain restriction said that x cannot equal negative 6 or negative 4. Drats. That means one of my answers that I worked so hard for doesn't count. So our final solution is x equals 5 because I have a domain restriction of x is not equal to negative 6 and negative 4. Oh my gosh, that was awesome. Look at that screen. Look at all that math. So much fun. So, as promised, this one is going to be my last example. First thing I want to do is deal with this kind of funky denominator. We like our denominators or our factors to be written in x equals or x plus something. We want to start with x. So I'm going to start by factoring that. I know that 5 minus x can be rewritten as negative x plus 5. Well, now I don't want to start with a negative, so I'm going to factor that out, and I'm going to get negative 1 times x minus 5. So now my new problem is actually negative 5 over x minus 5 minus x squared over negative 1 times x minus 5 equals negative 2. I'm going to do one last little trick here before I start to think about domain restrictions and all that good stuff. This is a subtraction problem, so I'm subtracting a negative. Well, I can just add instead and not have to worry about that when I'm thinking about my least common denominator. You can keep it as a subtraction problem, but that just means you're going to need to include negative 1 in your least common denominator. To me, that seems like a little bit too much work. So, domain restriction. In this case, our domain restriction isn't too bad. The only thing we have to worry about is that x cannot equal 5. Our least common denominator needs to just include x minus 5, since negative 2 is just negative 2 over 1. So we can go ahead and multiply through by that least common denominator. First fraction cancels out, and we are just left with negative 5. In the second fraction, it also cancels out, so I'm left with x squared equals negative 2 times x minus 5, because it doesn't cancel out on that side. So now let's do a little bit of math to simplify. We've got to distribute. So we're going to end up with negative 5 plus x squared equals negative 2x plus 10. Now I see that this is a quadratic, so what we need to do is get it to equal 0. Since x squared is over on the left-hand side and it's positive already, I'm going to move everything to the left. That means I'm going to add 2x to both sides, and I'm going to subtract 10 from both sides. So what we're going to end up with is x squared plus 2x minus 15 equals 0. It's minus 15 because those are like terms and I combine them. So now what we need to think about is factoring. Yay! We are looking for numbers that multiply to be negative 15 and add to be positive 2. In this case, we end up with x plus 5. We end up with x minus 3. So our two solutions for this problem are x equals negative 5 and x equals 3. Now, think about your domain restriction. I'm coming up here. If x equals negative 5 and x equals 3, and I have a domain restriction of x cannot equal positive 5, I'm actually okay. Nothing cancels out. X can equal -5. X can equal 3 because neither of those clash with my domain restriction. So I'm done. That's my final answer. This problem wasn't too bad. Not going to lie, this is the second time I worked this problem. When I did it earlier, I missed a negative sign somewhere. I ended up with a problem that I had to solve using the quadratic formula. And I ended up with imaginary solutions. And it was really gross and disgusting. So I had to go back and check myself. So that just shows you how important it is to check your answers. Look at how easy that was. I'm sitting here going, oh my god, it took me twice as long to do this when I had when I had just missed one little negative sign. So, a word of warning is be very careful on these problems. They're getting really complex. There's lots of things that can trip you up. There's lots of little signs and factors and all that stuff that will make them trickier and wrong if you do one of those mistakes. Now I'm just ranting, so moving on to my recap. See, I didn't lie. That was the last one. This is our recap, though. For our solving rational equations, we want to factor everything first. You really don't have to do this as much in rational equations, but it's good to keep that thought in mind, because sometimes you do. Then you identify the domain restrictions. You remember, these are the things that make the denominators equal to 0. So they're usually in the form of x is not equal to something. Then, if possible, simplify any fractions if you can. I didn't really have a chance to do that in any of my examples. Then, you find the least common denominator and you multiply the entire equation by it. That will cancel out all your fractions. Then you have an equation to solve. Once you solve your equation, whether it's a linear one or whether it's quadratic, you need to check your solutions against the domain restrictions to discard any that don't work. Sometimes both of them work, sometimes none of them work. It all just depends. Then last but not least, this is really, really important. You have to celebrate your awesomeness because these problems can get pretty tedious. But again, we're using skills you already amassed. All we're doing is putting them together in one big problem. So keep it up. You can do it.